What is the probability of randomly selecting a green marble? Probability is what you want out of your total amount. So let's find our total amount. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We got 20 marbles. I care about how many of them are green. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 out of 20 simplifies out to a half. Now you can answer a probability problem as a fraction, but if you also want to be fancy, you can turn it into a decimal or a percent. So you have half chance of reaching into here and randomly selecting a green marble. It's a word. Remember probability? Hey man, roll these die, roll this number cube, and spin that spinner. Probability is the favorable outcomes, what you want out of the total outcomes. Okay, when I look at this, I have 4 different colors that are they're equally distributable, if that's even a word. If I spin this spinner, I'm just as likely to get a purple as I am to get a green, as I am to get an orange, as I am to get a red. Or for those of you who are colorblind, I'm as equally able to get a gray as I am to get a gray, as I am to get a gray, as I am to get a gray. So what's the probability of me getting an orange? Well, there's 4 possibilities, so the total outcome is 4. Only one of them's orange, so 1 out of 4. That's it. What's the probability of me getting a red or a green? Well, there's 4 possibilities here, so my total outcomes are 4. One of them's red, and one of them's green. So that's 2 possibilities, 2/4. And then one of you's like, oh, sir, can't you simplify that? Yes, I can simplify that. Not red. You're not red. You're not red. You're not red. So since you're not red, that's 3 options out of 4 possibilities. All right, how many of these are pink? None of them are pink. So the possibility of getting a pink is a 0. A big fat 0. Simple probability. Ooh, look at all these marbles, 12 in total. What's the possibility of me getting a red? There's 5 of them, and there's 12 total possibilities, so 5 out of 12. What's the possibility of me getting black or blue? I'll tell you something. You get me upset, there's a 100% chance of you getting black and blue. Get it? Bruising. That's 6 of them. 6 of these are black or blue out of 12, which simplifies to half. No, 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 no. What's the possibility of me getting non-green? Well, let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I didn't mean that one. 11 of them are not green out of 12 possibilities. Easy peasy. What's the possibility of me getting a rabid squirrel? None of these are rabid squirrels, so 0 is the possibility of me getting a rabid squirrel. Mr. Abbott, remember him? He hated squirrels. Do I have enough time to do this one? Yep, perfect. All right, so I have a deck of cards, which is 52 cards. Okay, now just a quick look at it. Half of these are black, half of these are red. What's the probability of me getting a red? Half. This is out of 52. What's the probability of me getting an even number? Well, you 4 are an even number. 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 And you 4 are an even number. That's 5 groups of 4. 5 groups of 4. So 5 groups of 4 is 20. 20 out of 52. That was supposed to say 20, but there's a bit of a lag. Both of those numbers are divisible by 4. So if I divide the top by 4 and the bottom by 4, I get that. So the probability of me reaching into a random deck of cards and getting an even number is 5/13. A jack, queen, or king. So 4, 8, 12. 12 out of 52. Those are both divisible by 4 again. So divide the top and the bottom by 4. You get 3 out of 13. A black odd number. Ugh. All right. So I'm just actually going to count these out. A black odd number. So 1, 2. Oh, odd. Oops. 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 out of 52, which is going to be 2 out of 13 after you simplify it. And then I have an even club or an ace. So even club is, I guess that's the club. Even club. 1, 2, 3, 4, 5. Or an ace, 6, 7, 8, 9 is 9 out of 52. Can't divide it at all. That's that. The table summarizes the number of public schools in 2 California counties in 2017. So you got LA, you got San Diego, and all that information right there. Public middle school will be, okay, so this is a little different from just the regular old totals. A public middle school will be selected at random from the 2 counties. So it doesn't say which one, so I'm probably going to need this number at some point. What is the probability to the nearest hundredth of selecting a school in San Diego County? So what the question is asking us is if I decide to pick out of a pool of 287 middle schools, which one am I going to pick, or how likely is it that I pick one of those middle schools from San Diego? So I get that number right there. I don't know if this is a calculator section or not, but this to me is awfully close to like 150 over 600, which is very similar to 25%. So I'm going to go with 0.28. Again, this is very, 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 but not exactly, very similar to 150 over 600. That's how I view it. That gives me 25%. And since this 165 is a little bit more, and since 587 is a little less, that kind of tilts it a little bit more than 0.25. So that's why I went with 0.28. So I'm going with C for this guy right here. What is the probability of randomly selecting a green marble, putting it back, and selecting a blue marble? All right, this is compound probability. In this jar, we have 20 marbles total. I counted ahead of time. First, I want to pick a green marble. I counted the green marbles, and there's 10 green marbles. So our probability of pulling out a green marble is 10 out of 20. Now we're taking that marble and putting it back. So once again, we have ourselves 20 marbles. So I have a total again. Okay. If I want to find the probability of selecting a blue marble, I have 3 blue marbles. So my probability of selecting a blue marble is 3 out of 20. When you have compound probability, you multiply the fractions together. I'm going to simplify that guy to 1/2. So I have 1/2 times 3 over 20. 1/2 times 3 over 20 is 3 over 40. So this problem, which is called replacement, by the way, because I put my marble back, says what is the probability of getting a green marble, putting it back, getting a blue marble in that order? 3 out of 40. What is the probability of randomly selecting a blue marble, keeping it, and selecting a red marble? Right now we have 20 marbles in here. So selecting a blue is going to be 3 out of 20. So once that blue marble is gone, that leaves me now with 19 marbles. What's the probability of me reaching in here and randomly selecting a red marble? Well, I have 1, 2, 3, 4, 5, 6, 7 red marbles. And when you have two things going on, this is called compound inequality. Since I kept that marble, it's called without replacement. What you do is you multiply the fractions, you get 21, and 20 times 19, I'm pretty sure, is 380. Those guys do not simplify, so that is your answer, 21 over 380. How many possible outcomes exist in the example? A math quiz has 5 multiple choice questions. Each question has 4 options, A, B, C, or D. Ooh, let's do a little fundamental counting principle. And of course, you can't spell fundamental counting principle without fun and prince and count and ting. But what you do when you have several things going on is you use the fundamental counting principle, which means you multiply. So problem number 1, question number 1, how many options do I have? 4. Question number 2, how many options do I have? 4. Question number 3, 4. Question number 4, 4. Question number 5, let me see, 4. And you multiply everything in between. And 4 times 4 times 4 times 4 is 1,024. So that's how many options there are. So one option is A, and A, B, and A. And if you were to do that, you would have to do that 1,024 times. So that's the fundamental counting principle. See, I told you it was fun. A bookstore manager will randomly select one of 5 newly arrived fiction books and one of 4 newly arrived non-fiction books for a window display. What is the probability that the manager will select the shortest of the newly arrived fiction books and the longest of the newly arrived non-fiction books? All right, so let's, 1 of 5 fiction, let's let that be the black pen. So the probability that the one that you choose is the, what do they want, the shortest? The shortest of the fiction books is going to be 1/5. The probability of the nonfiction books being the longest is going to be 1/4. When you have multiple probabilities going on, compound probabilities, you multiply those together. 1 times 1 is 1. 5 times 4 is 20. 1/20 is the same as 5%. And that's your answer there. There are 28 students whose last name begins with the letters G, H, or J, or K. Information about the probability of randomly selecting one of these students is listed below. Okay, so basically there's a bunch of people. I select a bunch of them. 28 of them have like Gonzalez or Hernandez or Jones or Katz with a K. The probability of selecting a student whose last name begins with G is 1 out of 7. What does that mean? All right, well, if there's 28 students that fall under this category, and 1 out of 7 is a G, 1/7 times 28 means 4 kids have the last name that start with a G. All right. Probability of selecting a student whose last name begins with a G or an H, is 5 over 14. So if it's 5 over 14 and there's 28 students, that means 10 of them have a G or an H. How did I do that in my head without having to think fractions? Well, 14 is half of 28. So if you were to double 14, you'd have to double 5 too. So 10 have the last name of G or H. The question here is, how many of these students have a last name that begins with H? Well, if it's G or H and there's 10 of them, but 4 of them have a last name that start with G, let's get rid of that 4. Let's just pretend I did that on purpose. 6 people have a last name that starts with an H. The answer is C. Dunzo. A forest contains different species of trees. Let T represent the total number of trees in the forest. H represent the total number of hickory trees. And K represent the number of oak trees. Okay, if a tree is selected at random from the forest, which expression represents the probability of selecting a tree that is neither hickory nor oak? All right, so whenever you do probability is what you want over the total. That's how probability works. In this case, the total amount of trees is T. All right. It tells me that H is hickory, K is oak, because, oak starts with K. And it's asking me, we want everything but that. All right. So you take your total and you subtract out the K and you subtract out the H, and that's going to be the probability. So, that's pretty much how you do it. Don't overthink it. Now, of course, I wrote it out of order, but B is the only one that matches up. They have T minus H minus K, where I have T minus K minus H, same thing, over T. B is my answer. That's how you do probability. Interesting. Fun, though. List all the possible permutations. You got yourself a smiley face, a sun, and a heart. Well, permutations is how many ways can I reorganize this thing? Well, thing number one is I got smiley face, I've got the sun, I've got the heart. So that's way number one. If I were to start out with the smiley face again, my other option is smiley face, heart, sun. So let's start out with the sun. If I start out with the sun, I could do sun, heart, smiley face, or I could do sun, smiley face, heart. As you can see, I'm not much of an artist, especially when I start to get lazy. What didn't I start out with? Heart. You should always lead with that, am I right? Then smiley face, and then the sun. And then last but not least, heart, sun, smiley face. So 6 of them. And those are all my possible permutations, which means how many ways can I rearrange this to create something unique? Well, there they are. Evaluate 8 permutations taken 5 at a time. There's 2 ways to look at this, okay? This is the lazy way to look at it. 8 times 7, 2 times 6, 3 times 5, 4 times 4, 5. So what you do is you write out what 8 factorial is until you do 5 numbers, but I don't want to use that. That's just a lazy way. That's a lazy way. Don't want to do it. Don't want to do it that way. The permutation formula is if you're given, and let me actually write it all out. If you have NPR, National Public Radio, NPR is n factorial over n minus r in parentheses factorial. So this is my n, this is my r. So I have 8 factorial over 8 minus 5 factorial. Remember, factorial means you start out with that number and you multiply one integer less until you hit 1. So 8 times 7 times 6 times 5 times 4 times 3 times 2 times an unnecessary 1. Now this is the same as 3 factorial. So 3 times 2 times 1. Now, I know that when I'm multiplying straight across the numerator and straight across the denominator, that anything that's the same up here, that's also the same down there, I can just cross out. So this happens, which means I end up with 8 times 7 times 6 times 5 times 4, just like I did up here 2 minutes ago. Now, the reason why I'm showing this step is if the numbers are nice, then I could just multiply these guys together. Well, the numbers aren't nice, and I can't do that in my head, so I did it in the calculator ahead of time, and I got 6,720. Perms, not just for hair anymore, they're also for mutations. Like and subscribe. Find the number of unique permutations of the letters in every word, every. I don't know why I said every before every word. It should be the word, but whatever. Every. Well, there's 5 letters here, but the thing that's very important is 2 of those letters repeat. If none of the letters repeated, it would just be 5 factorial. Then I'd call it a day and everybody would be happy, but that's not what I have at all. I have 5 numbers where 2 numbers repeat. If you are asked to take a permutation, okay, and that's what we have when you're rearranging things, and it says permutation, you do NPR. Okay, the total number of objects you have, you're taking R of them at a time. And depending on how many repeats you have, you just take that many factorial, do it again if you have to, do it again if you have to, so on and so forth. Okay, so if I was asked to do like Mississippi, for example, I have a bunch of P's repeating, I have a bunch of I's repeating, I have a bunch of S's repeating, and I might do like 2 factorial. For like the P's, and I don't know, I could take 4 factorial for the S's, MISSISS. So yeah, whatever. Here, I'm being given 5 total letters, and I'm taking all 5 of them at a time. And that's going to be over the fact that 2 of my letters repeat, and that's the only things that repeat. So 5P5 is the same as 5 factorial over 2 factorial. Let me write it down here. 5 factorial is 5 times 4 times 3 times 2 times 1. And 2 factorial is 2 times 1. Now, if you have something across the top that's same as the bottom and all you're doing is multiplying straight across, you can get rid of them. And now I don't really need a calculator. 5 times 4 is 20 and 20 times 3 is 60. So there's 60 ways that I can rewrite every to create a different thing. And again, since 2's repeat, I'm not going to be like, let's do EEVRY and then switch these E's to make EEVRY. No, in this case, these guys are the same, so we're not going to repeat ourselves. And that's why I divide everything by 2 factorial, so I can get rid of all those repeats. That's it. List all the possible combinations if I give you 3 letters T, V, and W taken 2 at a time. All right, so with a combination, the order doesn't really make it any different. So TV and VT are the same thing. So I have T and V can match up, I have T and W can match up, and I have W and V, or VW, Volkswagen, can match up. And that's it. And if you're wondering, well, what about WT? What about WV? Nope. Combinations, we don't care about the order. So I only have 3 of these guys. That's it. I'm done. Evaluate 18 total combinations, but only taking 5 at a time. I have NCR, and the formula for NCR is n factorial over n minus r factorial. And before you yell at me and say, this is the same as permutations. No, it's not, because this guy adds an r factorial also on the bottom. So what I have here is I have, you're my N, you're my R, I have 18 C5, which is 18 factorial over N minus R factorial. So let me see, 18 minus 5, 13 factorial times R factorial, which is 5 factorial. Now, this might be overkill, but I'm going to write this all out and then all of a sudden start using common sense. I have 18 factorial. Let's write that out like I said I would, and then I decided I wouldn't do it. 18 times 17 times 16 times 15 times 14 times, ouch, my hand hurts. So I'm just going to write 13 factorial. I could write 13, 12, 11, 10, but wait a minute. 13 factorial is already on the bottom. Oh, let's just get rid of those. And then I have 5 times 4 times 3 times 2 times 1 from that 5 factorial right there. Now, I'm going to make life a little easy. 15 is the same as 5 times 3, so we can cross those out. But unfortunately, there's not much more I can cross out. So if the numbers were a little bit more pleasant, maybe I can pull that off and get some numbers that I can multiply together in my head and be okay. That doesn't really happen here. So I ran to a calculator ahead of time and found out that this whole thing ends up being 8,568. Okay. So that's combinations. With combinations, something like VT and TV are the same exact thing. We don't worry about order. Order doesn't really matter like it does in permutations. That's why that extra R factorial is there, because order doesn't matter. If I were to give you something like TV and VT, I'm just going to say, well, those are the same thing, so let's kind of get rid of all those repeats. But that's what I have here. Those are combinations. Baby. Cody is carrying 7 pages of math homework and 3 pages of English. Oh, that's the way it should be, Cody. Math is more important. A gust of wind blows the pages off of his hands, and he is only able to recover 7 random pages. What is the probability that he recovers all of the math homework? Well, we have 7 maths, and we have 3 Englishes, giving us a grand total of 10 pieces of paper. All 10 of them are laying on the ground. He picks up one of them. The probability that he picks up a math one is 10. Then he picks up another, but there's only 9 left. Also, there's only 6 math ones left. Then he picks up another one when there's only 8 total papers left, and there's 5 total math ones left. Oh, pretend that I didn't put that dot there. That means nothing. I'm trying to lead to something. All right, 7 total pieces of paper left. 4 of them are math. 6 total pieces of paper left. 3 of them are math. 5 total pieces of paper left. 2 of them are math. 4 total pieces of paper left. The last one is math. Whenever you're doing probabilities and you're doing different probabilities, different events at the same time, you multiply. Multiply, multiply, multiply. That's the fundamental counting principle. And I'm not going to pretend like I did this all on my own. I didn't. I used the internet and I got 1 over 120. So you're thinking, oh, 7 out of 10 pieces of paper. I'm probably going to pick up all math. No, you're probably not going to pick up all math. Probably not at all. And the probability of me getting only 7 pages of math, even though there's more maths than English, is not high at all. It's 1 out of 20. That's less than 1%. That's how you do it. A class has 6 girls and 5 boys. If the teacher randomly picks 6 students, what is the probability that she or he will pick exactly 3 boys? 3 boys. All right, so we've got 6 girls, 6 G, and 5 boys, giving us a total of 11 children. Okay, so me closing my eyes and picking, what am I doing? A boy is right now 5 out of 11. Me picking a boy again, well, there's 10 students left, is going to be 4 out of 10. And me picking a boy again, if there's 9 students left, is going to be 3. Now I have to pick only girls. So there's 8 students left, 6 girls, 6 out of 8. 7 students left, 5 of them are girls. 6 students left, 4 of them are girls. When I multiply all of this together, I end up with 5 out of 231. So not very likely. Not very likely at all. But this is me closing my eyes with a room that's nearly half boys, half girls, and saying, I only want the guys. Probably not going to happen. You're probably going to pick a girl. But it's possible. It's not likely.
Hey, y'all. Peyton Manning here, quarterback for the Denver Broncos. And I'm here to teach y'all how to find permutations or combinations on your calculator. So let's see what we got going on here. We have ourselves our TI-73 calculator. And looks like we got a question. Let's read it, shall we? Peyton Manning, that's me, has 4 MVP trophies. That's pretty good. how many ways can he arrange two of them? Now, we have to figure out if this is a permutation or a combination. I know it's a permutation because of that word there, arrange, which means I care about order. So the way we will organize this is, since there's 4 trophies, 4 of them, and we arrange 2, we're going to find 4 permutations taken 2 at a time, which means I have to type in 4 permutation 2. Well, how do I do that? Let's find out. Let's go to our calculator. First things first, I have to type in 4. So type in 4. There you go. All right, 4. You're doing great. You're doing great. Now I have to put my permutation symbol. So I'm going to go to math, hit math, and go over to PRB, which looks like probability. And there you are, NPR for permutations and total are at a time. Not to be confused with the radio station. I prefer country music. So let's go down to 3, 2, 3, hit enter. Now I have to put in 2 because we're doing 4, taking 2 at a time. And it looks like our answer is 12. So to answer our question, there's 12 ways that Peyton Manning, me, can organize my 4 MVP trophies, taking 2 at a time. Very good. Before we end, though, I have one more question to take a look at, and here it is. The Denver Broncos have 53 players. How many groups of 3 can I make? Now, what I'm going to do is I'm going to look at this and notice that order does that not matter. It doesn't matter how you choose 3 players. It could be me, Peyton Manning, or Eric Decker, or Champ Bailey, or it could be Champ Bailey, Eric Decker, me. It doesn't matter the order, so this is a combination. 53 total players taking 3 at a time. So we're going to solve this the same exact way. We're going to type in 53, 5, 3, go back to math, hit math, go to probability again, go to NCR, hit enter. Now we're taking 3 at a time, hit 3, hit enter, and it looks like our answer is 23,426. There's 23,426 ways that I can make a group of 3 if given 53 players. Yippee-yi-yo-ki-yay! How exciting is that? Boy, howdy, that's more exciting than bull riding on a Christmas afternoon. All right, y'all, thanks for watching. I'm Peyton Manning. Go Broncos! How do I turn off? What button do I hit? Is it that one? No, it's not there. Oh, there it is.